Our first topic is, so these are the topics we are covering under forms of condensation, that is dew, frost, fog. Fog and mist are combined in your book, and cloud. So basically we have 4 forms of condensation in your book. Let us start with dew first. Now, dew. Deposited moisture in the form of water droplets on cooler surfaces. You have already seen dew. First let us read, then we will explain it in further details. Now, when the moisture is deposited in the form of water droplets on cooler surface of solid objects rather than nuclei in air above the surface, such as stones, grass blades and plant leaves, it is known as dew. Underline this. What happens when the air which is having a lot of moisture in it, right? When it reaches a temperature which is low, now what will happen, instead of sticking to the particles which are present in the air, it will stick to another surface of the any object like stones, grass. Even if you wake up early in the morning, you will see small droplets of water forming on the windows, right? Why this takes place? Because the temperature is lower at the night and the water which is present in the atmosphere gets cooled down and gets deposited on the surfaces. Now, the ideal condition for its formation, for dew formation, what should the condition should be? The sky should be clear, calm air, high relative humidity, that means the moisture which is in the atmosphere must be high, and cold and long nights. Only when these conditions are fulfilled, then only dew will form. You will see dew does not form in summer months in our areas, but it forms in the winter season. Now, for the formation of dew, underline this, it is important. For the formation of dew, it is necessary that the dew point is above the freezing point, that is 0 degrees Celsius. That if the temperature falls below 0 degrees Celsius, another process will take place, that is called the frost formation. Okay, I hope you understand the difference between dew and frost. When the temperature is above the freezing point, it will be resulting in dew. But when the temperature falls below the freezing point, the water vapor will get accumulated into ice form, and that is called frost. They are very similar, so don't get confused. It is very easy to remember as well, students, that dew is water and frost is ice. Now, frost forms on cold surfaces when condensation takes place below freezing point, that is 0 degree Celsius. Write this, underline this in your book. The dew point is at or below the freezing point. Now, the excess moisture is deposited in the form of minute ice crystal instead of water droplets. What happens when the temperature goes below the freezing point? The moisture that is in the atmosphere, the moisture present in the air, it will not get converted into liquid form or water form. It will get converted into minute ice crystals, which will get deposited on plants and other surfaces. The ideal condition for the formation of frost are the same. Okay, the condition that we learned in dew, they are the same in frost as well, except one point, that except that the air temperature must be at or below the freezing point. Temperature is very important in the formation of either dew or frost. When it is below the freezing point, it will result in the formation of frost. But when it is above the freezing point, 0 degrees Celsius, when it is above that, it will result in the formation of dew. Otherwise, all the other conditions of frost and dew are the same. Now, our next topic is fog. Fog we are also familiar with. We have seen fog a lot in our life. Now, when the temperature of an air mass containing a large quantity of water vapor falls, all of a sudden condensation takes place within itself on fine dust particles. Now, dew is taking place, dew and frost both are taking place on surfaces, right? But when the water droplets get accumulated on the hygroscopic nuclei, what will happen? Fog. Okay? So, the fog is a cloud with its base at or very near to the ground. Underline this as well, that the fog, what is fog? It is a cloud which is very near to the ground. Okay? Because of fog and mist, the visibility becomes poor to 0. Fog also affects visibility, as you can see in the picture. We cannot see it clearly. Why? Because fog is formed here. Now, in urban and industrial centers, smoke provides plenty of nuclei which helps the formation of fog and mist. In urban center where there are a lot of factories, a lot of smoke is emitted from the vehicle, what happens? There is a lot of smoke particles for the water vapor to get accumulated on. Now, such a condition when fog is mixed with smoke is described as smog, that is S-M-O-G. The only difference between the mist and fog is that mist contains more moisture than the fog. Underline this as well. There is a difference between mist and fog. Okay? What? That the mist contains more moisture. In mist, each nuclei contains a thicker layer of moisture. Mists are frequent over mountain as the rising warm air up the slope meets a cold surface. We see fog on plains or plateaus, but in mountains we will see mist. Okay. Fogs are drier than mist. They are prevalent where warm currents of air came in contact with cold currents. Fogs are mini clouds. Underline this. Fogs are basically mini clouds in which condensation takes place around nuclei provided by the dust, smoke and the salt particles. So what is happening in fog? That the air, the water vapor is getting cooled down, but instead of sticking it into surfaces or falling onto the ground as water droplet, it is just getting condensed around the dust particles, the smoke particles which are present in the atmosphere, which are present in the air. Okay, when this happens, the visibility of the air goes from poor to zero and we cannot see clearly. As obvious as we saw with dew and frost, the fog also gets formed in the morning time only. Okay, very rarely do we see fog in afternoon day. Now, our next topic is clouds, okay, which is the fourth form of condensation. Up until now, we have covered dew, frost, fog and mist, and the fourth one is cloud. Okay, now what is a cloud? We have all seen clouds in the sky, correct? Now we will further learn about them in the details. We will also learn the types of clouds as well, which is a new topic for you all. Now, cloud is a mass of minute water droplets or the crystals of ice formed by the condensation of the water vapor in free air at considerable elevation. Now, there is a very small difference between fog and cloud. We learned that what is fog? हमने क्या पढ़ा? That fog is basically a cloud which is formed at lower elevation, which is formed at a lower height near the ground. Cloud, the same process is taking place, the condensation is taking place, but now this time it is happening at considerable elevation. Now, cloud is being formed high in the sky. As the clouds are formed at some height over the surface of the earth, they take various shapes. Now, clouds also have various shapes, as you might have already seen. Now, what we do is we have classified clouds as well. According to their height, expanse, density and transparency or opaqueness clouds, they are grouped under four types, that is cirrus, cumulus, stratus and nimbus. So, let us discuss these four types of clouds. Now, the first type of cloud that we have is cirrus cloud. Now, cirrus clouds are formed at high altitude, that is from 8,000 to 12,000 meters in the sky. They are thin and detached clouds having a feathery appearance, as you can see in the picture here. These clouds have a feathery appearance. Okay. Now, they are always white in color. Cirrus clouds are always white in color. Okay, moving on, the next cloud that we have is cumulus cloud. Okay, cumulus clouds look like cotton wool. They are generally formed at a height of 4,000 to 7,000 meters. They exist in patches and can be seen scattered here and there, and they have a flat base. Okay, they are formed when moist warm air bubbles escape vertically from the earth's surface, and these clouds are called cumulus. Next we have is stratus clouds. Okay, now stratus, as the name implies, they are layered clouds covering large portions of the sky. These clouds are layered and they cover a large portion of the sky. These clouds are generally formed either due to loss of heat or the mixing of air masses with different temperatures. So you should underline the basically the appearance of these clouds. We have learned that cirrus are feathery appearance, cumulus are cotton wool appearance, and stratus are layered clouds. The fourth cloud that we have is nimbus clouds. Nimbus clouds are black or dark grey. They form at middle levels or very near to the surface of the earth. These are extremely dense and opaque to the rays of sun. Now, nimbus clouds are very, very dense and they are opaque. Sometimes the clouds are so low that they seem to touch the ground. Nimbus clouds are shapeless masses of thick vapor. So, if we are supposed to describe the appearance of the clouds, you will simply say that cirrus, they are feathery in appearance, cumulus, they are like cotton wool, stratus, layered clouds, and nimbus are shapeless masses which are of dark color. Now, what we have done is a combination of these four basic clouds can give rise to the following types of cloud. Now, different types of cloud also combine, that is, as you can see here. Now, high clouds, we have cirro, cirrostratus and cirrocumulus, which forms at considerable height, that is cirrus, cirrocumulus and cirrostratus. Basically a combination of clouds at higher elevations. And then we have middle cloud, that is altostratus and altrocumulus. Also, we have low cloud, that is stratocumulus, stratus and nimbostratus, which are the rain clouds. Now, apart from that, we also have vertical clouds. Clouds with vertical development means instead of horizontally, these clouds are so large that they appear in vertical size, that is cumulus and the most important cumulonimbus, which are also called thunder clouds. Okay. Now, our next topic, student, is precipitation. Now, what is precipitation? The process of continuous condensation in free air helps the condensed particles to grow in size. We have already discussed the condensation process in just a summary form. Now we are learning about precipitation in detailed form. Now the process of continuous condensation in free air helps the condensed particle to grow in size. When the resistance of the air fails to hold them against the force of gravity, they fall onto the Earth's surface. When the water vapor present in the air, what happens when the moisture gets too much or when it gets cools down? The air cannot hold it, and what happens then? They fall back because of the effect of gravity. So after the condensation of water vapor, the release of moisture is known as precipitation. After the condensation of water vapor, the release of moisture is known as precipitation. Underline this. This may take place in solid or liquid form. As you can see here, that water is getting evaporated to the sky, then it falls down back. Okay, this process is called water cycle, which you have already learned. But in this particular topic, that is precipitation, we are only discussing the process by which the water is falling down. So what happens after evaporation take place? The warm temperature, the warm air rises up, cools down above the Earth's surface, okay, and then the water particles get so cooled down that they cannot fly anymore. The air cannot hold them, and so they get heavy, and because of the effect of gravity, the moisture falls down in the form of either liquid or solid. In liquid form it is called rainfall, in solid form it is called snowfall. Okay, I hope it's clear. Now, precipitation takes place in different forms. Okay, when the temperature is lower than the 0 degree Celsius, precipitation takes place in the form of fine flakes of snow and is called snowfall. When the temperature is way too low for the air, okay, the water vapor directly gets converted from gaseous state to solid state by the process of sublimation, and that is called snowfall. Now, what happens? The precipitation which is falling back on the surface of the earth may vary in different forms. When it is in liquid form, it is called rainfall, but when it is in solid form, it is called snowfall. Now, what happens? Moisture is released in the form of hexagonal crystal when it is in snowfall form. These crystals form flakes of snow. Besides rain and snow, other forms of precipitation are sleet and hail. Okay, we will learn about these in details now. Now, what is sleet? We all know what is rainfall and snowfall. Now, there are two terms that we have to discuss, that is sleet and hail. Now, sleet is frozen raindrops and refrozen melted snow water. When the water is falling down from the sky, what happens? It gets frozen because of the cold temperature. When a layer of air with the temperature above freezing point overlies a sub-freezing layer near the ground, when there is a temperature of air which is at freezing temperature, so the water particles, the water drops which are passing through that air, what will happen? They will get frozen and will result in the formation of sleet. Okay. Now, raindrops which leave the warmer air encounter the colder air below. Raindrops which leave the warmer air encounter the colder air below. As a result, they solidify and reach the ground as small pellets of ice not bigger than the raindrops from which they are formed. As you can see a picture here as well, you can see raindrops, but they are not raindrops, they are sleet, which means they are frozen drops of water. They are called sleet. Okay, they are formed when a layer of air with the temperature above freezing point overlies a sub-freezing layer near the ground. Supposedly, when they are falling, okay, there is a temperature of air which is cool, but another layer of air is there which is colder than that. So what will happen? When they pass that second layer, they will get frozen from water to ice. Okay. Now, we will come to hailstones. Sometimes drops of rain after being released by the clouds become solidified into small rounded solid pieces of ice and which reach the surface of the earth are called hailstones. Now, what are hailstones? When the water vapor solidifies into large particles, into large chunks of ice, that is called hailstone. They are formed by the rainwater passing through the colder layers. Hailstones have several concentric layers of ice, one over the other. So, these were the formation of rain, snow, sleet and hail. Now, our next topic is types of rainfall. On the basis of origin, rainfall may be classified into three main types, that is convectional rainfall, orographic rainfall and cyclonic rainfall, or frontal rainfall they are also called. Now, we will first discuss the convectional rainfall. Okay, so as I told you, these are the three types of rainfall that we have, that is orographic, cyclonic and convectional. Now let us discuss these in details. This is convectional rainfall. First, let us read. Now, convectional rainfall is very easy to understand. See, the air on being heated becomes light and rises up in convection current. The air becomes heated and it rises up, as we have already learned. When it rises up, it takes water vapor along with that in the sky. Now, when it rises up, it expands and loses heat. Consequently, condensation takes place and cumulus clouds are formed. Cumulus clouds, also called the thunder clouds, I told you, right? Now, with thunder and lightning, heavy rainfall takes place, but this does not last long. What happens? The air is getting warmed up, takes the water vapor with them. Upon reaching considerable height, the water vapor cools down, and when they turn back into liquid state, they fall back on the surface of the earth along with thunder and lightning. That is called convectional rainfall. Simple water cycle जो हम शुरू से पढ़ते आए हैं, right? But these rainfall do not last long. Such rain is common in the summer or in the hotter part of the day. It is very common in the equatorial region and interior parts of the continent, particularly in the northern hemisphere. Now, the next amount of rainfall that we have is orographic rainfall. Now, orographic rainfall is a little tricky, so please pay attention here. Now, what happens when the saturated air mass comes across a mountain? It is forced to ascend, and as it rises, it expands, the temperature falls, and the moisture is condensed. Now, what is happens? Supposedly, there is a cloud. Okay, the cloud is coming from this direction with the wind. Now, what will happen when it reaches a mountain? When it reaches a mountain, it will rise up with the mountain surface. Upon rising up, the rising air will cool down. Okay, it will cool down the cloud. Now the condensation process will take place, and the water vapor which the cloud is holding on, it will fall back on this side of the mountain. Okay, that is called the windward side. Right? Now what happens after the cloud has reached the summit? Now after it has reached the summit, the cloud will start to descend now. Correct? Now this cloud is deprived of all the water vapor it had before. Now it will collect the water vapor from this side. So what is happening here is, at one part of the mountain there is a lot of rainfall, and on the another side there is very less rainfall. This side is called the windward side, or this side is called the leeward side, also rain shadow area. Now the dry air will advance in this area. This area will receive very less rainfall as compared to this area. This rainfall happens when moisture clouds they face a mountain. They are forced to rise up. Upon rising up, the condensation process takes place and they fall down on one side of the mountain. When it reaches the summit, it is forced to advance down. Okay, it is forced to go down back now. It collects the atmosphere moisture from this side. Okay, and this is called the leeward side, where rainfall is very less. The process, this process takes place in India as well. When the Arabian Sea monsoon winds come to India, they face the Western Ghats. Okay, and Western Ghats orographic rainfall takes place in that area when the wind comes from Arabian Sea. Now our next topic is cyclonic rainfall. Now cyclonic rainfall or frontal rainfall. Now what happens in cyclonic rainfall? We all know what is cyclone. Cyclone happens when it is caused when warm moist air moves toward cold air. Okay, when warm and moist air, okay, and cold air collide. So you see, when warm air and cold air collapse, when they collide to each other, they never mix. What will happen is, the rising warm air will go above the colder air. When the rising warm air goes above, it will condense high above the ground and it will fall back. Okay, on the colder air. Now when these two dense air will meet each other, they will start a process called cyclone, when they will start revolving around each other, and cyclone will take place. Upon the formation of cyclone, which forms on the oceanic area, it will start throwing water vapors from the ocean area into the surrounding land area, and that is called a cyclonic rainfall. Warm air and cold air don't mix as they have different densities. Now our next topic is this is our next topic, that is distribution of rainfall, how much it rains in different parts of the earth. Now, different places on the earth surface receive different amounts of rainfall in the year, and that too in different seasons. In general, as we proceed from the equator toward the poles, rainfall goes on decreasing steadily. As we move on from the equator toward the pole, the rainfall amount decreases. As we have already learned in previous chapter, that the major insolation is being received around the equatorial region. Okay. We have Amazons here, we have the deserts here, and subtropical climate, that is, the equatorial climate, right? Now, The coastal areas of the world receive greater amounts of rainfall than the interior of the continent. As you can see, the coastal areas which are connected to the water, they are having more amounts of rainfall as compared to the interior of the continents. Now, the rainfall is more over on the oceans than on the land masses of the world because of being great sources of water. Between the latitude 35° north and 40° north and south of the equator, the rain is heavier on the eastern coast and goes on decreasing towards the west. But between 45° and 65° north and south of the equator, due to the westerlies wind, the rainfall is first received on the western margins of the continent. What happens? Rainfall is received first on the western margins of the continents. Okay, here there is South America, Africa, Europe and Asia. Whenever mountains run parallel to the coast, the rain is greater on the coastal plain on the windward side and it decreases towards the leeward side. As I just told you that in India, we have the western Ghats here which run parallel to the western coast of India. Now what happens when the air clouds, the moisture clouds will take place? When they will enter India, they will encounter the western Ghats, right? Now these coastal areas, because they have a mountain area, as we learned in orographic rain, what happens when it will encounter the mountainous area, it will start raining here first and then it will go again ahead of the country. On the basis of the total amount of annual precipitation, major precipitation regimes of the world are as identified as below. Now, first is the equatorial belt. Now, the windward slopes of the mountain along the western coast in the cool temperate zone and the coastal areas of the monsoon land receive heavy rainfall of over 200 cm per annum. So, the areas near the equator, they receive heavy rainfall as well as the areas which are located near the coast. They receive heavy rainfall throughout the year, that is more than 200 cm annually. Now, interior continental areas receive moderate rainfall varying from 100 to 200 cm per annum. Now, interior continental areas are these. These are the intercontinental areas which are not located near the equator. As you can see, this part of America and Canada, this part of Russia and Asia and Africa. Now, they receive moderate rainfall varying from 100 to 200 cm per annum. The coastal areas of the continent receive moderate amount of rainfall. Now, the central part of the tropical land and the eastern and interior part of the temperate land receive rainfall varying between 50 to 100 cm. This here, as you can see. Okay, these are the central part of the tropical land in the eastern and interior part of the temperate land which receive 50 to 100 cm per annum. So, these are heavy rainfall, moderate rainfall and this is low rainfall area. Now, there are another areas which is very low rainfall where less than 50 cm takes place. Here are the areas with rainfall less than 50 cm per annum. Areas lying in the rain shadow zone of the interior of the continent. Now, those areas which lie in the rain shadow area, for example, the area after the Western Ghats, as also areas which are located away from the oceans. Now, these areas will receive less rainfall, that is less than 50 cm per annum. Seasonal distribution of rainfall provides an important aspect to judge its effectiveness. In some regions, rainfall is distributed evenly throughout the year, such as in the equatorial belt and in the western part of cool temperate regions. So, there are some areas where it rains plenty of, but there are some areas which rains very less. So, students, this was the chapter of our geography, chapter number 11, water in the atmosphere. I hope you learned the chapter well. Go through the video thoroughly and take care.